Let's look at another constraint over here. So this is an example of pulley constraint again. So let me describe the system first. Okay, there are two blocks M1 and M2. This block M2 is attached to a string which is blue in color, and this particular string goes over this pulley. Let's call this pulley P1, and again it will go over another pulley. Let's call this P2, and again it is tied at this end. Okay, so this is near pulley P1. Okay, so this is a fixed end, so it will not move, and pulley will rotate. Okay, and here another block M of mass M1 is attached with the green string with the pulley P2. Now as this particular mass M2 will go down, this particular mass M1 will be dragged towards right. Assume that the surfaces are frictionless, all the surfaces, and the string is inextensible. That means the length of the string will not change. So how we will solve this question? So let me tell you what is the question first. I didn't tell you. If I know the velocity of this mass M2, or let's say speed as v, then what will be the speed of mass M1? That we have to find out. So how we will find out? Let's see. So suppose this pulley P1, I will take it as my origin, okay, or any reference point. Okay, let's take this as origin. And let's take the position coordinate of this pulley P2 with respect to P1 as x. Okay, so x just is the position coordinate of pulley P2 with respect to P1, and this particular length, okay, this particular length that is from pulley P1 to the mass M2 will be y, suppose. Okay, so I am erasing other things which are not necessary as of now. So this is y. Okay, so again this will also be x. Okay, so now the length of this blue color string will be 2x plus y, because 2 times x we have to take here, plus y is equal to L. Now if I differentiate, what I will get? 2x dot plus y dot is equal to L dot, but L dot is 0 because L is constant, the length of the string will not change. So here what is this? 2x dot is equal to minus y dot. So what do we infer from this? What we see here from this is that the position coordinate of this particular pulley P2 is x dot, and this particular mass M2 is y dot. Okay, so velocity, okay, this is velocity, position coordinate is x for P2, and for M2 it is y. Now the rate at which this particular coordinate y increases is nothing but the double the rate at which this x coordinate decreases. Okay, I will repeat again, the y will increase at the rate which is the double of that of the decrease of x. Okay, so this means velocity of y, okay, velocity of block M2, I will write velocity of block as velocity of M2 is equal to minus 2 times velocity of pulley P2. Okay, so this is the relation. But now velocity of P2 will be nothing but velocity of mass M1, because again this constraint is that P2 is attached to the mass M1. Okay, so this string will be tensed, and as a result the same velocity that is Vp2 velocity will be the velocity of Vm1. So we will find out that Vm2 is equal to minus 2 times Vm1. See, this minus sign is just because this y coordinate is increasing and x coordinate is decreasing, that's why. But if you see the magnitudes, you can see that the velocity at which M2 will go down is nothing but the double that of the velocity of M1. So given velocity of M1, you can find out velocity of M2, which is nothing but double the value.